Hi, my name is Allison and I am a biology major from the class of 2019.
And my name is Brittany, and I'm an environmental management and protection major from the class of 2018. We will begin working through practice problem number 6 from chapter 4.5 in the general chemistry workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem. Then we'll go over it together.
Now that you've attempted the problem, let's work through it together to make sure you understand each component involved. First, let's read the problem together and highlight the important facts. We know that we have a hydroxide salt and that it contains a group 2 cation. We dissolve 4.3 grams of the salt in 50 milliliters of water and then titrate it with 232 mils of 0.5 molar hydrochloric acid. Notice that the 50 milliliters of water was not underlined because it is simply used for dissolving the unknown salt and does not affect the titration result. Now that we understand the components of the problem, let's write out the balanced equation. We have an unknown group 2 cation with a hydroxide, so we will denote that as MOH2. That is added to HCl. Through this reaction, we form the unknown bonded to 2 chlorine atoms because it is a group 2 cation, and then water. Now we should balance out the equation, and we should get 1 of the unknown hydroxide, 2 of the hydrochloric acid, 1 of the unknown chloride, and 2 of the waters.
Okay, now we are ready to begin dimensional analysis. Let's begin with 232 milliliters of hydrochloric acid. We will convert this into liters of HCl, as there are 1,000 milliliters in 1 liter. Then we will convert it into moles of HCl, as we know the molarity of the solution is 0.5 molar. And finally, we will convert it into moles of our unknown hydroxide. Through our equation, we know that it is a 2-to-1 ratio of HCl to our unknown. Through multiplication, we see that the units cancel out. We have milliliters of HCl with milliliters of HCl, liters of HCl with liters of HCl, and moles of HCl with moles of HCl, which leaves us with our moles of our unknown, which should be 0.058 moles of our unknown. Now that we have our moles of unknown hydroxide, we can convert it into the molar mass of our unknown. We were given that we have 4.3 grams of our salt, thus we will take 4.3 grams of this salt and divide it by 0.058 moles. Which will give us 74.1 grams per mole. Continuing on, we will now subtract the mass of 2 hydroxyl groups from the 74.1 grams per mole of our unknown to get the molar mass of just our unknown cation. Through this, we get 40.08 grams per mole of our unknown cation. Now looking at the periodic table, we can see that our calculated molar mass of 40.08 grams per mole exactly matches the molar mass of calcium. So we see that our unknown cation is indeed calcium. Therefore, our salt is calcium hydroxide.
Hopefully, this video has helped you improve your assessment of stoichiometry problems and has shown you some key skills that are utilized throughout chemistry.